What is iterative design and engineering? Imagine building a model airplane. You make a wing, test how it flies, see what needs fixing, and then adjust the design. This cycle repeats until the plane flies just right. That's the essence of iterative design in engineering. It's a way to develop products by going through repeated rounds of creating, testing, and improving. Instead of trying to get everything perfect on the first try, engineers use this process to make smarter, more reliable designs over time. The process starts with defining the problem clearly. Engineers figure out what needs to be solved, like making a car engine more fuel efficient or a drone more stable. Then they brainstorm ideas and develop initial designs or prototypes. These are basic models or parts that can be tested. For example, a prototype might be a small-scale version of a new gear system or a digital simulation of airflow around a vehicle. Next, the prototype is tested. Engineers gather data on how it performs in real or simulated conditions. They look for flaws, weaknesses, or areas that can be better. If a prototype doesn't meet the goals, they analyze what went wrong. Maybe the gear wears out too quickly or the aerodynamics aren't optimal. Based on this feedback, they refine the design, making adjustments to improve performance, durability, or cost. This cycle repeats multiple times. Each iteration builds on the previous one, gradually leading to a better product. For example, in automotive design, engineers might use computer-aided design software to simulate airflow, then build a physical model to test in a wind tunnel. After each test, they tweak the shape to reduce drag and improve fuel efficiency. This process can take several cycles over weeks or months, depending on the project. Compared to a straight-line approach, iterative design is flexible. It allows engineers to adapt quickly when new information comes up. It also helps catch problems early before full-scale production, saving time and money. In aerospace, for instance, iterative testing of wing designs helps optimize lift and reduce weight without waiting for a perfect model upfront. In mechanical engineering, this approach is used everywhere. When designing a suspension system, engineers simulate how it handles bumps and turns. They then build a prototype, test it on a track, and refine the design based on the results. This cycle continues until the suspension performs just as needed for comfort and handling. Iterative design encourages learning from mistakes. Instead of seeing failures as setbacks, engineers see them as steps toward a better solution. It's a practical way to handle complex problems where initial ideas might not work perfectly. By repeating the cycle of designing, testing, and refining, engineers develop products that are more effective, reliable, and suited to real-world use. So, in simple terms, iterative design in engineering is a process of making something better step by step. It's about building, testing, learning, and improving again and again, until the final product is just right. This method is fundamental in creating everything from tiny mechanical parts to large machines, helping engineers turn ideas into successful working solutions.